what I'm going to cover, a very brief company overview, and then we're going to talk about the mobile technology itself. I'm going to not try to get too technical, but just kind of talk about how the system works, and that helps kind of inform the types of environments that you can scan. And then we're going to talk about the ZEB family, and ZEB for us is essentially anything that is hardware. So talk about some of the different hardware products that we have and the different industries that they're applicable to. A little bit about the software, so GeoSLAM Hub and Draw, and then some data examples as well. So GeoSLAM is a market leader in Go Anywhere 3D mobile mapping technology, and by Go Anywhere we really do mean that. So that the technology allows you to take LiDAR and essentially put it in your hand. So anywhere that you can walk to collect data, you are able to do so. In fact, it is incredibly versatile, where some people don't just use it as a handheld device, but in fact mount it to drones, to robots, and to different systems in order to capture the data. So it is a very versatile piece of equipment that allows you to capture data in places that previously that was unheard of. So we actually came from the mining industry, where people were really keen to map underground caves in order to kind of plan building foundations and to understand where sinkholes may or may not appear. And after we really nailed down that sector, all of a sudden we started to get inquiries about 2D floor plan generation, and that's really where it took off. And now we're really owning that survey in terms of 2D measured building survey space really strongly at the moment. So some of the different industries that we obviously are active in the top left, and as David mentioned there, Microsol resources are really a key player there in the AEC market. So whether that is somebody that is an architect or a surveyor, they're definitely able to use some of the GeoSLAM systems. I will talk about it in a moment, but simplicity is really at the core of what we do. So not only does the technology allow you to put the LiDAR system in your hand, but it also means that the software and the downstream workflow is as simple as we can make it, so that you don't have to have a master's degree in surveying in order to get great data. So some of the other industries is conservation, and specifically forestry in that example. Obviously into education, so different universities and institutes have different discount bands, so we definitely do sell into the education vertical as well. Facilities and asset management, that's a really new space for us. So, or at least for the past 6 to 9 months, being able to map out these spaces in order to tag the different assets that are available, and being able to continually go back and scan to keep your models up to date and live is something that's really taking off at the moment. As I talked about mining as well, security, defense and military, it is also something that we do sell into as well. So just a quick look at some data, just to kind of make sure everyone knows what we're talking about. So as we can see here is a 3D point cloud. All our systems collect fully 3D LiDAR data, so it is not just a 2D floor plan. We are collecting completely in 3D, meaning you can take that data into the kind of BIM 3D modeling space, digital twin type space, and that can still provide real value. I guess what's really key about this data set here and the next one is, even if you do have really difficult to reach spaces, so whether that is a long corridor, whether it is an area with lots and lots of stairs, because the LiDAR sensor is in your hand, it's not on a tripod, it's not on a trolley, you're able to just walk and collect that data. And we can see here the point cloud in green and the trajectory in it going from red to blue. So really you're able to take it into lots of different environments and collect data. And then I'm pandering to the audience a little bit here, but this was a data set that's maybe 2 years old now, of the Lincoln Memorial. And what I really wanted to show here is, even in quite congested spaces, you're able to collect good data. As you can see, just at Lincoln's feet, essentially, there's a crowd of people all moving around. So we're still able to collect data in congested spaces. So whether it's a pretty example like we see here, or whether that is an office space that is active and there are people moving around, we're still able to collect data without causing downtime for the people that are leasing the space. So that's a really, really key point. So a little bit about the technology. As I said, don't worry everybody, I'm not going to go into too much detail, but what I wanted to say here is a little bit about what SLAM is. So GeoSLAM, the company, and we specialize in our SLAM algorithm. And SLAM doesn't just sound cool, it's not just a marketing term, it actually does mean something quite scientific. So simultaneous localization and mapping. So that is essentially our magic sauce, if you will. It allows us to take the LiDAR data and really run with it. So you can see here on the left, laser data measurements and IMU positional data. So we're able to, this is the information that we have in your hand. So the LiDAR sensor, as well as essentially an accelerometer, similar to what you would have on your phone. And we use that to measure gravity so that your data comes out nice and level. And we take these two data sources, you walk around the environment, and what the SLAM algorithm will do is it will recognize features in the space of which you're walking in order to build up that map. So if you've seen a certain wall before, it can bring that part of the point cloud back on top of each other, and it's an automatic registration process. Whereas maybe with a tripod-based scanner, you have to do some more advanced techniques in order to register different scans together. So that SLAM algorithm is a completely automated process. You drag and drop that into GeoSLAM whole-bar software, and automatically it will process and generate you that 3D point cloud. So some of the big benefits is you don't need to remain static. I would argue it's even better if you go quite quickly to collect the data, and there's also no need for GPS. So a lot of these environments we're talking about, whether it's underground or inside of a building, collecting laser data is very, very difficult because you don't have that control points that GPS would give you in a normal kind of topographic type survey. So SLAM allows us to go into these environments and automatically start to generate point cloud data. So touching on that, and it's a kind of a technology that most people are familiar with. So on the left, we've got a GPS or GNSS, and you can see our antenna is connected to lots of different satellites. And because it's connected to all them different satellites and we've got a wide spread, it means our positional information is really, really good. And the same is true with GeoSLAM technology. So we can see here on the right, there's an underground type environment, and where we've got lots of geological features around us. So our position will be really, really good. And the same is true for when you're in a building. So you can see constantly walls, doors, windows, the floor, the ceiling, and that means you can go very, very quickly and collect that data in a very robust fashion. So I kind of touched on some of this already. So the kind of core values of what GeoSLAM are trying to do. So on the left there, speed, that's a big paramount thing for us. So the fact that the LiDAR system is in your hand means that you can do a single room, if it's small enough, in a matter of seconds, rather than having to set up a tripod and collect a data set and then making sure that you also collect another tripod data set where the doorway is, and so you can link it through. That whole workflow, which may take a few minutes, takes seconds for us. So speed of capture is really, really key for us. And the next point there is simplicity. So I touched on it a little bit earlier, the fact that our software is very, very simple to use and is very, very accessible, and there's no need to be a surveyor. And that is true of a lot of our customers. They range from archaeologists to construction site workers to miners in underground caves. So you definitely do not need to be a surveyor to collect good data. The clever stuff happens later on when you bring all that data into your Autodesk package to do the complex work. And then also quality. So GeoSLAM has been used on probably more than thousands of projects at this point, and it's been used in lots of different industries. So it's a very robust algorithm, and we also have incredibly robust hardware to enable that algorithm as well. So then a little bit about the products. So I'll just talk about some of the different systems and the differences between them, but I'll really focus on the ZEB Revo system because that is most applicable to you guys and to Microsol. So the ZEB family, as I mentioned earlier, ZEB means hardware in the GeoSLAM universe. So on the left, we have the ZEB Revo. So that was a product that we launched in 2015. A handheld system with a really high IP rating, and most people use that system for the underground mining type environments. And then further to the right, that is the ZEB Revo RT. So we use the same sensor, which is really a robust sensor in terms of calibration and repeatability, but it also has a really good precision as well on the sensor. It's also RT, so it's real time. You're able to see that data on the tablet being built up as you walk. And most of our customers that are scanning for 2D floor plans, 2D measured building survey work, or for 3D modeling and BIM purposes, they usually go with the ZEB Revo RT device. But the other two devices here, so center left is the ZEB Horizon, a product that we launched last year. And the big uplift here was that 100-meter range. So the fact that you're able to collect so much data means that SLAM is really robust. We've been testing it at 35 miles an hour and still been getting really great data out of it. So we're really excited about the ZEB Horizon. And I'll talk a little bit more on that shortly. And then center right is the ZEB Discovery. And this is a product that we launched last week into Geo in Germany. And essentially we're taking the ZEB Horizon technology, that 100-meter sensor, but we're also pairing it with fantastic imagery so that you're able to really understand the point cloud, measure information from the imagery, and start to do different types of tasks. So whether that is kind of street mapping in urban canyons or city mapping in complicated, difficult to reach areas, the ZEB Discovery is a fantastic piece of kit. But I will talk about that shortly. So as I mentioned, the ZEB Revo RT is a fantastic piece of kit, launched in 2017. And the big difference here for the ZEB Revo RT is the fact it is real time. So the data is processed live as you're walking, which gives you this graphical user interface. So you can actually see where the scanner is, you can see the trajectory of where you've walked, as well as the point cloud being built up around you. You also get an indication of how good the SLAM is, so that SLAM quality feedback, essentially a traffic light indicator to let you know you can see lots of features or you can't see many features. So it allows you to change your survey live, go back to an area where the SLAM is confident, and maybe try and traverse that section a little bit differently. So in terms of being able to deliver great data more often, the ZEB Revo RT is fantastic. A lot of our customers that are non-surveyors also use the RT system. So here we've got halve your survey time, and that survey time is referring to other ZEB systems, so other GeoSLAM systems. This is twice as fast. Compared to traditional tripod methods, this is arguably 10 times faster. As I mentioned, that ensuring full coverage of the data, so the fact that you can see it built up on the tablet really allows you to see, have I captured everywhere I've needed to get to? And I know that sounds very simple, but when you're in a 15, 20-story building, it can get quite confusing and quite repetitive. So seeing that on the screen is a fantastic advantage. And all these things together really mean an improved data accuracy. So a little bit in terms of the specification of the ZEB Revo RT. So the range of the sensor is 30 meters. So this is not really an outdoor type sensor. It is very much internals and getting the measured building survey work kind of done. It is an IP51 rated sensor, so or rated system, sorry. More than enough for buildings, whether it's a dusty environment or not. We can colorize the point cloud. We do have camera accessories like we can see in the drawing here. It does not collect intensity. That is one of the big differences between Revo and Horizon. And the only other point to pick up here is that the relative accuracy being 1 to 3 centimeters. So what we're talking about there is the complete global accuracy. So if I was to scan a 15-story building from the bottom left corner to the top right corner, we're talking about 1 to 3 centimeters accuracy. If you're in a single room, what we're talking about there is plus or minus 15 millimeters. Okay. And I will also talk about the ZEB Pano. So the ZEB Pano is an accessory for the ZEB Revo RT. And as you can see here, it's a carbon fiber telescopic pole with a 360 camera mounted to the top. And what this really allows you to do is add contextual information to the point cloud, so that you can, if you walk into a room, you trigger the camera, collect that 360 image, and then go off again to collect more point cloud data. So you can really scale it up, capturing as many images as you want or as few images is necessary, so that the point cloud can be better understood. I think time and time again, more people are collecting data, and not necessarily being the team that are processing the data later on. More often data is being shipped off to, maybe it's India or to China, to be processed and turned into a 3D model, and giving both a small data size so that it's easy to transport, but also giving that extra information so that they can determine whether that part of the point cloud is a bookcase or whether it's an extension of the wall, is really, really important when it comes to the reliability of generating that model. And what we can see here in the bottom screen capture is actually an export that we can do from our software using the web export function. And it allows you to see the point cloud in the top left as a 2D slice, as well as little circles where all the images are taken, and you can click through them and actually see the different images and relate them to the point cloud. And this can be done from Microsoft Edge or from Google Chrome, so that different stakeholders are able to both measure the data, but also understand what's been collected on site. So we're really allowing that connectivity and that shareability of data. So as I talked about the ZEB Horizon, we've got that 100-meter range, and what we're talking about here with intelligent point clouds is essentially that we can collect intensity data. So the fact that we get a measurement of how reflective the surface was can be really important for certain applications. In terms of indoor, a lot of new customers to us who have been mapping large-scale car park facilities have been really amazed the fact that they can collect the data so quickly, but they're now also able to see all the road markings because the horizon picks up that reflectivity. Has been a real win for us. As I talked about, the range of the system is that 100 meters. So now the ZEB Horizon is UAV ready. It's been out since last year, and people have been using it to collect all sorts of data via a UAV system. Strongest ever SLAM in terms of the Horizon, and that really refers to the fact that there's so many points we collect, and the greater range of the system means SLAM can see so many more features that it's much more effortless in terms of the data capture. There's not a lot of best practices you need to follow. It's very, very simple in terms of capture. So I will just touch on some of the things here. So as I said, 100-meter range, slightly better IP protection, so IP54. It is available in a backpack. We can still colorize the point clouds, although we do get better results from the Horizon than from any of the other systems. And we do create much more points, so 300,000 points per second, as opposed to the 43,000 points from the Revo. But we still have the same relative accuracy, so that 1 to 3 centimeters. So from one corner of a building to the opposite corner of the building, it's still at 1 to 3 centimeters, but you will get a slightly worse precision from the ZEB Horizon. It's slightly noisier compared to the ZEB Revo. And as I mentioned there, so it is UAV ready. It is very simple deployment. We do have a UAV mount, which includes a damper and some safety security cables to make sure that the system obviously doesn't drop off. And then more or less it's ready to go. So there's no additional sensors that are required for positioning. You do not need to integrate the GPS. Essentially, you can start the system and away you go. I think one thing to really touch on here about LiDAR and UAV is that if you, or generally the way the systems in the market work, is you either have a fantastic LiDAR sensor, which will weigh quite a lot, and that means that you can't have a rather heavy and expensive IMU system, which you would use for your positioning. Or you have the converse, you have a very good IMU, your positional information is great, and then you have to, I guess, take a hit on the quality of your LiDAR system. What we do really differently, because the two systems are integrated and we use the SLAM algorithm, it means that we can still put great LiDAR systems up there, but we don't have to have a very expensive IMU system as an additional cost. It all comes together for the ZEB Horizon, meaning that the point cloud that comes out is really, really robust, but it means there are no artifacts and positioning problems, which is very common with LiDAR on a UAV. And then a little bit about the ZEB Discovery. So the ZEB Discovery is a backpack system using the ZEB Horizon. It does have clip-on and clip-off abilities, so you can use the same ZEB Horizon, clip it onto the backpack for a backpack acquisition, and then disconnect it and use it as a handheld device. And this is the type of data that we get out. So you can see both the point cloud and high resolution imagery on top of each other. And we can actually, measure from the imagery, because in the background, the point cloud is present. The backpack also has a GNSS integration. So we're able to globally position where the data is captured. So this is something that we can't do with any of the other systems straight out of the bag. So then a little bit about case studies and some of the different examples. So this is a British example from a company called Omega Geomatics, and they had a real big challenge. They had a space which was, it's actually a residential home or an old person's home, which is obviously occupied 24 hours a day, and they didn't want to, I guess, interrupt their residents, making it difficult for them and cause any stress. And they also wanted to be in and out as fast as possible. So they didn't want to remove people from their homes, but they also didn't want to be there for a long period of time. So using the Revo for their internals, but also using GNSS and survey outside of the building was the workflow that they proposed. What they were able to do is do 2 site visits, and they were able to then produce the drawings within a single day. So a 30-minute scan was able to capture all the data that they required. Their 2 site visits was obviously that they needed to put in control around the building, but the 30-minute scan from the ZEB Revo allowed them to collect that data really, really quickly. And you can see here that they've quoted that the scan to use tripod-based scanning would have taken up to 3 days, and they would have had to remove residents from their different spaces. The average accuracy that they received from our system was that 15 millimeters, so plus or minus 15 millimeters across the entire survey. So this is really high accuracy. They followed the best practices in order to get that type of result. And they were able to obviously save a lot of money because they didn't have to push out the entire field team for a longer period of time, and they also didn't disrupt the space too much. I think what's really key about this study, obviously we're talking about a residential space, but if you're talking about a really large building with lots of different occupiers in different units, it can be really, really a challenge to not interrupt all them different businesses and to not have to come to the site multiple times in order to get permissions. If you turn up with the right permissions, obviously, but also saying that the scan will only take 5-10 minutes, people are a lot less likely to object to that data being captured. This is another European example, so a company called Lifa in Denmark. So in Denmark, it is a legal requirement that floor space is mapped for different leaseholders, so that when they're renting the spaces out, it is obviously done based on the floor space that's available to them. So it's a 13-story building, and they were able to capture the data in 1.5 hours, which was rather remarkable. So you can see, obviously, sorry guys, all in meters and centimeters again, but you can see the scale of the building, and you can see how complicated these different stairways are. To be able to capture these stairways using a tripod-based scanner would take a significant amount of time. So being able to just walk up and down the stairs for the capture is a real cost saving. And the accuracy that they got on this scan was within the 5 centimeters, which was the tolerance that they need to hit for this type of work in Denmark. And then obviously they took the data, we can see the point cloud here in Navisworks, and then they used this point cloud data to inform them to build up an Autodesk Revit model. Obviously it takes a little bit quicker than that video shows, but it kind of shows the type of work that can be done with just 1.5 hours on site. And I will also briefly touch on the software. So this is a part of our software called GeoSLAM Draw BIM. So this is an additional cost. It's an upgrade from the basic GeoSLAM Draw package, which does come as part of the package with all our systems. But GeoSLAM Draw BIM is a really nice plugin to Autodesk Revit. So if you are new users or you're looking to speed up the initial part of your workflow, you're able to select the elements in Autodesk Revit, but take the measurements directly from the point clouds in GeoSLAM Draw, and the measurements will automatically fly over to Revit. So the location of the measurements are true, but also the measurements and dimensions can fly through straight away as well. So you don't necessarily have to bring the point cloud into Revit, although I'm sure as Microsol customers, you're experts at doing so, but this is just a possible option for you guys. I didn't quite finish the video off there. There we go. So you can see very quickly they can start to build up a 3D model. So I think this only took them about 45 minutes to start building up a model like this. And then the last data example for you guys. So this is a great example of using 2 different systems. So this is Boston City Hall, and they captured the outside of the building and some of the internals using the ZEB Horizon. And then some of the internals were captured using the ZEB Revo RT. And then the 2 data sets were brought together, and they were then used to create a Revit model. So you had something in fully 3D that was then be able to use by the town hall, which is a fantastic data set, and I'm sure you might have seen it online already.